welcome back. Today's topic is miniature circuit breaker. We often call it as MCB. I think you might be seeing it in your homes and offices and all other places. Nowadays, we are using MCB in the place of fuses. In the last lecture, we have seen about fuses, right? We have seen the advantage and disadvantage of fuses. We have seen the desired properties of a fuse material. We have seen that normally lead and tin combination, they'll be used for less than 10 amperes, and above that we will be using copper or silver. And if we do need a time gap, we will be going for the zinc. And there are different types of fuses. We have the very old ones, rewirable fuses, and next we had the cartridge fuses, and we had this PTC fuses also. And there are HRC fuses also for higher ratings. We do have these different types of fuses. So the choice depends upon the application. But there is a big disadvantage with the fuse, right? It is normally a replaceable one, which means we are supposed to replace it when it is blown off. Even though there are PTC fuses, but they are a little bit costlier and they cannot withstand higher current ratings. So to overcome this problem of fuse, which is to be replaced every time, we have moved on to the miniature circuit breakers. So a miniature circuit breaker is one which is fastly replacing the fuses in modern days. So today we will see what actually is an MCB, what is the need for MCB, what are the different types of MCBs, and the applications of different types of MCBs. So we'll have a look at all of these things in today's lecture. I'll start with, 1 minute. So I'll start with the introduction to circuit breaker, and then I'll move on to the construction and components, and then I'll move on to the working of circuit breaker, how it works, how it gets tripped, and how it gets reset. And then we will move on to types of circuit breakers. It depends upon the current rating, so I'll just give a glimpse of classification of circuit breakers. And finally, we'll compare the fuse and MCB in terms of different properties and features. So let me start with an MCB or a miniature circuit breaker. It is just an electromagnetic device which is just like an enclosure. You can see it in this format. There will be a switch, right? I'm not a good artist, but this will be a switch type of thing. So this is an enclosure. Inside this electromagnetic device will be there. It is normally made up of insulating material. So the main purpose of your MCB is to switch the circuit. It is just like a switch and turn on or turn off. The thing is that the switches generally or normally they will be manual or automatic, but it depends upon the user, right? But whereas an MCB, it is an automatic device when tripping off. So when you experience any maloperation or any fault, it will automatically trip off. It will automatically turn off itself. So that is a main feature of an MCB. That's a difference between an MCB and a switch. So the main function of an MCB is to switch the circuit. That is to open the circuit automatically when the current passing through it exceeds a value for which it is set. So it can be manually turned on and off as similar to your normal switch if necessary. So MCBs are time delay tripping devices. See, the characteristic will be just like your inverse current characteristics. The magnitude of overcurrent, how much current you are having, it controls the operating time. If it is too high enough, then the operating time will be very low. Okay, so these get operated whenever overloads exist long enough to create a danger. If it is only for a shorter duration, your MCB should not trip, right? So it will wait for some duration. If it is cleared, then it won't be tripping out. But it is still prevailing, then automatically your MCB gets tripped. So normally if you do have a sudden spike in current, for that things your MCB shouldn't operate. Your MCB should operate only for faults, right? If the current is persisting for a longer duration, then you should operate. So for normal spikes or for transient loads, your MCB should not operate. If it is a lightning or surge, then you should operate. Okay. So normally at the time of starting, your current will be high, right? If you suddenly turn on a fan or suddenly turn on your motor, suddenly the current will increase and slowly it normalizes. It is not a surge. It is a high starting current. For that one, your MCB should not operate. If it is high for a duration of time, then you should operate. Or if it is very spike because of a fault, then you should operate. So this characteristic will be embodied into your MCB. Okay. So they are designed to operate at less than 2.5 milliseconds during short circuit faults. And normal times, they will be operating at 2 seconds to 120 seconds. In case of overloads, they will wait depending upon the magnitude of current and then they will operate. So this is your circuit breaker. I think this picture will help you a lot to identify a circuit breaker. So you can find single pole circuit breaker. This is single pole 1. This is 2 pole. This is 3 pole. And this is multiple pole. Right. Normally this indicates that these are connected to two different switches, different loads. Okay. But these are predominantly used single pole, 2 pole, 3 pole. And in this one, single pole is rather used. We do employ 2 pole. Okay. So it is just like this is 1 pole and this is another pole. So it normally looks like when it is open, it will be like this. So when it is closed, it will be like this. The switches will be closing. When it is open, it will be looking like this. Even opening of one switch will result in open circuiting methods. For a 3-phase system, you will be using 3 pole. Okay. So it can be manually switched on and off as similar to normal switch. And it is manufactured in different pole versions. As single, double, triple and 4 pole structures are also available. But the common thing is double and triple are mostly used. For single phase, I go with the double. For 3-phase, I go with triple things. They are normally rated for 220 volts for DC supply and 240 or 450 single phase and 3-phase AC supplies. The current rating will be varying. If the current is too high current rating, then automatically the thickness will be varying. Okay, so they are mainly used for isolating your faulty sections and they can be used for protecting your devices. So multiple features are available for your MCBs. So they are used for local control switches, isolating switches against faults and overload protection devices. So these are the functions which are done by your MCB. And coming to what actually will be there inside an MCB, it's a big question, right? So you don't see anything outside. You'll be seeing only this poles. We call this one as poles. Entire thing will be included inside. So what actually will be there inside? So an MCB embodies a complete enclosure in a molded insulating material. And this provides you a mechanically strong property and insulated housing. So nothing is available outside. So in this, the switching system, it consists of a fixed and moving contact to which incoming wires and outgoing wires are connected. So the metal or current carrying parts are made up of copper or silver alloy to be more conductive in nature, depending upon the rating of the circuit breaker. So this is what will be present. See, this is your switch which you are use operator, right? This is your operating mechanism. You can turn it on or you can turn it off, right? And this is your space for identification, right? Now see here, this is what will be there inside the thing. This is your upper terminal, this is your lower terminal, rail holder, this is your moving contacts, this is your fixed contact, electromagnetic protection. Normally we use a solenoid or something. And this is an arc chamber where arc is basically extinguished. This is your thermal bimetallic strip which allows you to monitor the temperature. And this is the function. Okay. Now, when the movement of this one will help you, the moving contact, to get in contact with your fixed contact or not. If you trip this one, then automatically it gets open and there will be an arc formed here, and this arc will be extinguished with the help of your arc chamber. Okay, so this movement will define the movement between these contacts. Okay, and based upon this, you will be getting an arc. If it is low current, then you might not be getting an arc, but if it is high, you will be getting an arc and it will be extinguished. If it is not extinguished, then it will result in a short circuit. So it's about selecting the current rating of the circuit breaker. Now, as the contacts are separated in the event of no overload, you can see there is a fixed contact and there is a movable contact also. This is a fixed one and this is movable one. So in between these two, if you try to open this one, an arc will be formed, and all modern MCBs, they are designed to handle arc interruption process, where this arc energy is extracted and its cooling is done by providing some metallic arc splitter plates. See, these are metallic arc splitter plates. Okay. Now, these plates are held in proper position by an insulating material. Arc runner is provided to force the arc that is produced between the main contacts. This you will understand when you move on to the final year. So how does it work? So the tripping of the arc is the most important thing in your MCB. Okay, in your fuse it just goes off, melts off, so no problem. But here it is to work again, so we should trip the arc very carefully. So it provides you reliability. If it doesn't get tripped, then it is unreliable. So MCBs are supposed to be very reliable devices. So you are supposed to extinguish it very clearly. So operating mechanism consists of both magnetic tripping and also thermal tripping arrangements. So it is to be tripped whenever there is an overload, right? So how magnetic tripping is done? It consists of a composite magnetic system. You have seen the magnet there, which has a spring there attached to it. So a spring loaded dashpot with a magnetic slug, then a silicon fluid and a normal magnetic trip. To that, a current carrying coil in the trip arrangement. It moves the slug against a spring towards a fixed pole piece. So the magnetic pull is developed on the trip lever when there is sufficient magnetic field produced by the coil. And in case of short circuits or heavy loads, a strong magnetic field between which is being developed there by the solenoids, it will be sufficient enough to attract the armature of the trip lever irrespective of the position of the slip. Now, this is your, if you want, you can omit all the previous line. I won't be going into detail to ask you. So this is a transparent MCB where you can see what is actually happening inside. And if you open the MCB, these are the different components which you find. This is a coil, this is an arc splitter, these are the moving contacts and fixed contacts. So all these things you can find here. Okay, these are the components which are housed in this insulated material. Now, thermal tripping. Thermal tripping, normally it consists of a bimetallic strip, around which a heated coil is wound to create heat depending on the flow of current. The bimetallic strip, it consists of two metals, so which do have different melting and boiling points, right? So based upon the temperature, they will be taking a direction, right? The amount of direction which they will be bending, it depends upon the heat which is being developed there, or the temperature difference. So the heater design can be either direct, where current is passed through the bimetallic strip, which affects the part of electric circuit, or indirect, where a coil of current carrying conductor is wound around the bimetallic strip. In both of the cases, you will be getting temperature increased or decreased. So the deflection of the bimetallic strip activates the tripping mechanism. It is just like your fridge, which refrigerator, right? You will be having a bimetallic strip, which allows the currents. There will be two metals, metal 1 and metal 2. Depending upon the currents, both will be having different melting points. So they will be taking a shape. So automatically what happens? They will be getting tripped. When it is normal, they will again come back. See here, fridge also basically. It consists of an automatic thing, right? When the temperature is high, it gets tripped off. Otherwise, it will get back. So the bimetallic strips are made up of two different metals. Normally, brass and steel will be employed. They will be riveted and welded along their length. Two materials clubbed into one piece. Okay. So I won't go deep into this bimetallic strip. Let's see how it is going to work. See, this is a bimetallic strip. Normally, this is the way. This is the trip bar, this is the latch, and this is contacts. When you experience any increase in temperature, so this will be moving, this will be bending, and it will be touching this one. Once it is touched, see, this part will be, if it is touched, then this will be moving on this side. So the latch gets open, so the contacts, they'll get open. So this is the way how it is going to work. And there are 6 types of MCBs, A, B, C, D, E, K, Z. And this is the classification of MCBs.